You can multiply numbers and you can multiply radicals. You just can't add radicals. So for this one here, we had 5 root 8 times negative 3 root 3. We can multiply these two numbers, and you can multiply these two numbers. So when you multiply 5 times negative 3, 5 times negative 3 is negative 15. And then root 8 times root 3 is root 24. So your next step is to see if you can divide this by any perfect square. Is there a perfect square that will divide into 24? So looking at the front, those pink numbers, they're perfect squares. Which one of those numbers can I divide into 24? 4. 4 times what is 24? 4 times 6. So we're going to break this apart to 4 times 6. This negative 15 is still there. So then the square root of 4 is 2. And then your last step would be to multiply these together to get negative 30 root 6. Right there. Now, when you're adding or subtracting, you have to have like terms. So add or subtract. They have to be like terms. And what that means is they have to have the same number underneath the square root. And when you look at number 2, currently they're not the same. We have an 18 and we have an 8. So what we need to do is simplify them both individually. So 18 is not a perfect square, but if you look at those pink numbers in the front of the room, which number can go into 18? That is a perfect square. 9. So I'm going to break this apart to 9 times 2. And then the 2, bring that down. What perfect square goes into 8? 4. So we're going to break that apart to 4 times 2. So now we're ready to simplify. So the square root of 9, is 3. So this becomes negative 3 root 2. And then the square root of 4 is 2. So when you multiply the 2 in the front and then the 2 that's underneath the 2 that we get when we simplify the 4, we get another 4 because we're multiplying 2 times 2. So what I want you to notice is that now these are the same. And because they're the same, meaning that they're both root 2, if one was a root 2, the other one was a root 3, that wouldn't work. Because they're both square root of 2, that means that they're like terms. And because they're like terms, we can just add these numbers together. So what do you get when you add the -3 and the +4? 1. So your final answer is 1 square root of 2. You don't have to put the 1. Generally, we would just drop it and say that the answer is root 2. But again, I would accept either one because both are technically right. Any questions? All right, let's look at number 3. For number 3, we are multiplying, okay? When you multiply a binomial, we're going to make a box because I think that's generally the way you all would do that. I do have some of you who like to FOIL or use the distributive property, so that is an option. All right, so when we multiply the square root of 5 times the square root of 5, we get the square root of 25. And what is the square root of 25? 5. So in this box, we just have a 5. So we go from the square root of 25 to a 5. Yes. One more time. Yeah, you could if I understand your question correctly. Are you asking if it were just a root 5 instead of a root 5 minus 2?
No, the root 5 and root 5, they both have roots where they get squared.
Oh, I see what you're saying. Okay. So what we're doing is we're just multiplying the number underneath. So when you multiply these together, I mean, you could write it that way. You could say it's equal to the square root of 5 squared. And then that's going to cancel and give you a 5. Or you can multiply those two numbers to get 25 and then simplify it to a 5. All right, so now we're going to multiply. There's an invisible 1 right here because you cannot multiply the -2 by the 5 because this 5 is under a square root. You can't touch it. The only thing you can multiply that with is another square root, but not a number. So -2 times root 5 is simply 2, -2 root 5. And this square here, you would have a +3 root 5. And here you have a -6. So when we combine our like terms, these are like terms, which gives you a -1. And these are like terms, which just gives you a +, root 5. And that would be your answer. So we talked about imaginaries and how we can't have an imaginary in our denominator. The same thing goes with the square root. So no radicals can stay in the denominator. So you can't have no radical in denominator. So we have to multiply that in order to cancel it out. And that's actually called rationalizing. That's just a fancy math word, but not that important. So when I say we need to rationalize it, I'm saying we have to get rid of a square root. So you cannot leave a square root in the denominator. So in order to eliminate it, I'm just going to multiply by what I have in my denominator. So let's multiply top and bottom by the square root of 8. When we do that, we have 3 times 3, which is 24. And that's over 8 times 8, which is 64. Now, 64 is a perfect square. So that's going to change to an 8, which is what we wanted to do. We wanted to get rid of the radical. 24 is not a perfect square. But you always want to ask yourself, can I divide it by any of those numbers you see in the front in pink? So which number can go into 24? 4. So I'm going to break this apart to root 4 times root 6, which becomes 2 root 6 over 8, which is a good answer. And you would get almost all the points. But you do have to simplify. Now, when I simplify, am I dividing the 6 also? No, right? Only the 2 and the 8. You can only divide what's on the outside. And that is going to give you root 6 over 4. This is the final answer that I would be looking for. And you can put the 1 in front. All right, any questions? Yes. I didn't hear you. Yeah, you can put it here. It's right here. All right, so let's go ahead and look at number 5. We got some time, so we'll keep moving. Oops. All right, we're only going to do number 5, and then we'll end there. So go ahead and copy down number 5, and then that'll be it for today. I mean, I am going to have you copy down the other ones, but 5 might take a little bit of space, so. But as far as today's class, because we have our skills check, we'll stop at 5. All right, so just like number 4, we have to get rid of the square root. But notice the difference is this one has a -1 also. So here we have to multiply by the conjugate, which is exactly what we did with the I, where we have to flip the middle sign. So it's a little bit more complicated when there is, if it's not just the square root. So that means that I have to multiply top and bottom by root 2 plus 1. Root 2 plus 1. So we're going to do that. Let's do our numerator first, which is 5 times root 2 plus 1. And you're multiplying by the number only. So in front of this root 2 is a 1. It's just invisible, but it's right there. So I'm just multiplying the 5 by both of these 1s, which is going to give me a 5 root 2 plus 5. So that's my numerator. Now for our denominator, we should make a box. So that's going to give you root 2 minus 1 times root 2 plus 1. So let's go ahead and fill in our 4 squares. So we start off with The square root of 2 times the square root of 2, which is the square root of 4. And the square root of 4 is simply 2. So that's what I have in that first box. That first box just has a 2. The second box has a negative root 2, and this one has a positive root 2. And this has a negative 1. Whenever you multiply two conjugates, the middle two boxes always cancel. So these two are going to cancel out. So all I have left is 2 minus 1, which is 1. So my denominator is 1. So this is my answer. Now, do you have to put the 1? If the denominator is 1, do you have to write that? So you could also just say 5 root 2 plus 5. And this is the better answer. All right, we're going to stop there, but I want you to copy down 6, 7, and 8 so that we're ready to go for tomorrow.